Yeah, so hello guys. So you already know me, I'm Sean, and this time we are going to. Okay, I have to accept the admission. Okay, so we are going to work on SQL data analysis. So this is your tutorial for SQL data analysis. Uh, I will just move to the tutorial notebook and just run it. So now we have to talk about SQL. So what is SQL? So SQL is one of the most important common computer languages in use for working with data today. So it's the standard language for accessing and manipulating relational database. So while it is relatively limited compared to, oh, I don't know, guys, if you are able to see my screen.
John, I think your screen is not showing up.
Okay, let me share. Uh, like that. Okay, hop is working now. If you get, just say yes.
It's working, Sean. We can see
Okay,
your screen.
okay, sure. So I was telling what is SQL, and response. SQL is one of the most common computer languages in use for working with data today. So it's the standard language for accessing and manipulating relational databases. So while it is relatively limited compared to a general programming language such as Python, it is highly optimized for efficient retrieval and aggregation of data from database tables. So its broad support and use virtually guarantees that any professional data scientist or analyst will encounter SQL eventually. So furthermore, SQL is often the paradigm used to discuss the relational data model, which has implications that apply beyond SQL compliant databases. So here now in this tutorial, we are going to explore SQL from within Python, which allow us to work with SQL in a familiar setting, I mean from Jupyter Notebook, and also see opportunities for compatibility between the world of relational databases and the data science tool within Python. Yes, so all those things are going to be based on the relational data model. So what is the relational data model? Is for most of part correspond with the our intuitive notion of table. So in tables, you know, guys, we have a row and we also have columns. And a row usually represent some object event, and the column now is the attribute which will be used to characterize the relation, the event, the object. So the columns will just describe the row. So this is exactly what we call a relational data model. So now, for example, just consider the following table representing the order from an online retailers. So you can see actually there are several rows and there are also a lot of columns. So we have the information about the customers. I mean the customer's name and the customer's ID. You also have information about the order. So you have the order ID and you have the delivery address of the order, and you have information about the product also. You have the product ID and the price of the product. So in the above tables, we just reproduce it many values several times, such as the customer name, ID, addresses, price, and etc. So now we could just break up this table into several smaller tables in which relation contain the minimal amount of attributes, yes, needed to define a relation. Yes. So now, as I was talking, here we have several time customer name repeated. You also have the customer ID repeat, and you have also everything, the order repeated, and so one, and so forth. So what we are going to do now to work with our relational data model is just to break up this big table in small tables. For example, we may have to break it in two tables for customers, tables for product, and another table for others. So exactly like we did here. So here we have the customer tables, which describe information about the customers. So we have the customer name, we have the customer ID, and we have the billing address. And now we have another table, which is the product tables. Here we have the information about the product ID and the product price. And at the following is the table about the order. So the order tables contain information about the order ID and the delivery address, but we also have information about the customer ID and the product ID, because remember our model is actually a relational model. So we need to make a relationship between tables. So for example, if you are looking for the orders coming from these other tables, but in addition to the orders, you need, for example, the customer name who is making the order, or now the product the customer is actually buying. Then you will have to make a relationship between the order table and the customer table in one side, and the order table in the product table in the other side. So what are we going to use to make those relationships? We are going to use foreign key. So that's why we set the customer ID and the product ID in this table, so that we are going to use it later to call some more information from the customer and product tables. Yes, so this is basically what is called the relational data model. Yes, so the other thing is also that when you look at this table above, actually you have 7 row and 7 column. So this means that we are saving, we are storing about 49 cells. But when you look at those small tables, here we are now actually saving about 47 columns. 47 cells. So this may not be a huge improvement, but realistically, an online retailers may have millions of order in for a particular product, for example. So when the data are small, we don't see the difference. But once the data become bigger and bigger, you get the difference, because you are going to save a lot of space in your database system. So now let's explore how this will be implemented in SQL. And to do that, we are going to use SQLite. So SQLite is just a basic SQL database manager that is helpful for small data analysis and instructional purposes. So here we are working in Jupyter Notebook, and we are basically running Python code, but now we are going to run some SQL code. So to do that, we just have to set up our SQL environment inside the Jupyter Notebook. You know, basically the Jupyter Notebook code cells just contain Python code, let's say Python code. And now we want to use an external extension, an external function. So we want to use SQL functionality. So we have to set this functionality before we use it. So now we are going to use some magic command like a load extension command. So you write the load extension and you follow this by SQL to tell your Jupyter Notebook that be ready. We are going to use a SQL statement for the following. And now we have also to set up our SQLite database. So here we are just using this database for SQLite. So if I run this now, you can actually see that everything is set. So it's connected to our database. So this is the test DB, and we are going to use it to build our tables and everything else. So now we have three tables. We have the customer tables, we have the product tables, and we have the other tables. So what we have to do is to create those three tables in our database now. But before insert data in those three tables, we have to create the structure of these tables. So we have to create the tables and create the structure of the tables. So as we are running this as a first example, we could just drop the tables if they already exist. So the customer tables, we don't know if it exists, but if there is a table in our test TV that is called, which is called customer, just drop it before create a new one. So we drop it with those SQL function, drop tables if exists. Yes. So now, after that, we are going to create our tables. So we create the customer tables with the column ID, name, and billing address. And then we create the product tables with the column ID and product price. And now we create the other tables with the column ID, customer ID, and product ID. But in addition, apart from that, we have to specify how do we make references to the customer tables and the product tables when we are working on the other tables. So this is why we are going to use foreign key. We are going to specify that those two columns, because the customer ID already exists in the customer table and the product ID already exists in the product table. So why do we call those two columns here now? Just because we want to make some relationship between this table, other tables, and the one we have above. So we are going to specify this relationship by setting our customer ID and product ID as foreign key in this table. So we say set it as foreign key, and references are the ID in the customer table and the ID in the product table. Yes. So now we can we can easily make a connection between this other table and the product table and the customer table. So if I run this script, so we are going to see done. So we are connected to the test TB database, and all the tables are created now. So now, initially, our tables are just empty. Yes, but as I was describing, they already have the structure. So we just specify everything about the table. For example, see the columns. When we come back to the columns of the customer tables, we set the ID as an integer, and we set it as the primary key, and we say it should not accept null value. And the second column, we set it as a test because it's the name is a string. So we set it as a test, and we say it should also not receive null value. And same thing for the third one. So we did the same for all the three tables. And now here, as our table don't contain any data yet, we can just use the select function to display what do we have. Yes, so now you can see here the double percentage sign following by SQL. So this is just to tell the cells that the following lines of code will just be SQL code, SQL script, SQL command. So if I run that, we see that the other tables is displayed, but we don't have any data yet. We just have the colors name. So if I do the same for the customer, let me say, change it to customers, and I run it. Yes, so the table is there, the table exists, but we don't have any data yet. So I will do the same for products to be sure our tables are really empty before we move. Yes. So the product tables is also there, but we don't have any data yet. So how do we have data? Actually, we have to use the function insert. You guys know the insert into function of SQL. So this is basically the function we use to insert data in our SQL tables. So now we are going to use insert into function to insert data into the customer table and insert it into product table and so on and so forth. So the only thing I will refresh here is that we have to be careful to do this in a certain order. Yes, because we define relationships between our tables. Yes, so when we define the order table, for example, we define a relationship between the customer ID and the product ID attribute and the ID attribute of the customer and the product tables respectively. So now we can only insert data into the orders tables once the appropriate customer and product exist in the tables. So that's why I didn't start inserting data into the order tables. But I start inserting data into the customer and the product tables, and then I insert data in the order tables because I want the relationship work properly. Yes. So insert into will insert value in the table. So you guys know how to do that. So here we are inserting about 1, 2, 3 rows in our customer tables, and we are inserting 1, 2, 3, 4, 5 rows in our product tables. So if I run this, then we are able to see the results. So 5 row as affected, 2 row affected, 2 row affected, and 3 row affected. So that's okay. And remember our tables was empty. So now if I'm using the SQL function to run, we should be able to see some data exactly like the one we have above. So these are just the data we just insert using the command insert into. So we get 3 rows here. And if I do the same with the products, we get some data. And if I do also the same with the order, we should be able to see actually data. Yes, so this is a first way of making tables in our SQL database system. So here we are using SQLite, but in case we also have our data in save on disk, if we have our data in our disk so that they are formatted, they are saved in a CSV format, how could we actually get our data and patch them to our SQL database system? So now here is how we do. We just have first to import pandas because no, I say that the data are basically actually saved in a CSV format on your disk. Yes, so you just have, so here is the link. You guys know how to use a pandas point read point CSV to import a file from any folder in your device. So for myself, the data are located here. So I put them in the the C disk, and then in the 10 Academy folder, data, and then customer.csv. Yes, so I can just move on. I don't know if, okay, let me see if we, okay, this is the 10 Academy folder, but here are the data. Okay, so here you have the order tables, and here you have the product tables. And where is the customers? Where is the customer table? Can someone see? Okay, here we have the customer table. So if I try to open this, let me open with Notepad. So you can actually see what we have in the tables. So we have some data about the customers. Yes. So now I'm going to import those data first and save them in my data in my pandas. I will import them with pandas and save them in Python as data frame. So I will call the data frame customers, product, and others respectively. So if I do that, I now need to patch my data to my SQL database system. So as we are using SQLite, we are going to import SQLite first. And yesterday, I think on Monday, you just install SQLite using your conda prompt. So it should be working now. And you just have to import the SQLite library so that you are going to use it to set up first your connection. So here is the line to set up the connection. So I provided, I just give it a name and I say SQLite.connect and I'm connected to the database test.tb. So if I do that, I just import my data and I save them as data frames and then I patch them each to my SQL from my SQL connection to my SQL database. So the code to do that is just the one I write here. So we have the data frame customers. We say customers to SQL. And what should be the name of the customers data frame on our SQL database system? We name it customers. You could also change the name here if you want. Use the connection to patch it, and we don't need index. And now, if the tables actually exist, just replace. So now this is, I will just run it. Yes, and we have no error, so it's okay. Now I can just select to see what are the data I actually have in, okay? So we have the data, we have the order. So if you want, you can also select from customers, and you have some data. Yes, and if you also select from products, you will actually have some data also. Yes, so it's working. So now, moving to the next session, we are going to see how to use filter and sort function. Yes, so filtering and sorting are something we use to do when you are dealing with data analysis with SQL. You will be doing this every day. I know that because I'm experienced about that. I'm using that every day. If you want to query data using SQL, you will have to sort, you will have to filter. So this is why I select this function as very important to show you today. And it's nothing difficult. You know, we are just going to use where coming. You know, SQL code are just like when I'm writing the code, I just feel like I'm writing sentence. So you say select from where, so select ID, delivery country, from order, where we have this. So it's basically like you are just writing down a sentence. So I admit some are more complex, but those ones are actually easy. And I know you guys know that. It's just a refresh. So now here we are using the where function to filter our data. So select ID and delivery country from the other tables where we have delivery country equal to India and limit this to maximum 10 rows. Yes, so we use the where command to filter the delivery country to India only. So if I run this, actually, you will see that all the display row will be about India. So ID1, India, 2, India, and so on and so forth, because we use the where command to filter on India only. So now this is the same thing, but with the price. So last time I just used the equal operator to filter the delivery country. So here now we are using the greater operator to filter on the price. Yes, so here we select all from, so when we see this sign, this means return all the rows and all the columns. Return all the columns, I mean, because here we are limiting the row, the number of rows. So select all from products where the price is above 20. Yes, and limit to 10. So I run that, and we can see that all the display prices all the display product prices are just above 20. So the first one is 21, 24, for the second 29, 20, 27, and so on and so forth. So this is how we can do with where. Now we can actually combine the where function with the like function. So here, for example, I say select ID and delivery country from other where the delivery country like this. So this also is like a sentence. So we select from a table where we have the delivery country like something. So this where is actually used to look for some pattern in our data. So here, this pattern just tells us that the country, the delivery country should be starting, the delivery country name should be starting with S. So if we have put, we would have put the S at the end or after the percentage sign, this would mean that the delivery country name should be ended by S. But as we have provided the S before the percentage sign, this means the delivery country name should be starting by S, and we limit the result to maximum 10. So we print that, and you can see that all the display row have effectively delivery country started by S. So we have Senegal, Spain, and so on. So we have everything. So now here is another function used to filter data. So you can, the basic function is where, but you can actually combine the where with a lot of function. So here we are using the in. So in will be used to check if our condition is below a list. So here we provide a list for the customer ID. So we select all the data from the others where the customer ID in this list. So if I run it, you will see that the first customer ID is equal to 200 and 200 is here. The second one is equal to 200 and is here. The first one is, the third one is equal to 400 and is here. Same thing for the following. So the 10, you have it here. So you don't have actually any row which do not satisfy this condition. So if it will just check if the customer ID satisfy this condition is beyond this list before display the data. Yes, so this is how we combine the where function and the in to filters our data. And now you can actually also use the and or and not a function. So you just have to combine them with the where. So actually here we select all from other where customer ID in this list, exactly like we did above. And actually the delivery country not in this. Yes, so the not in is exactly the opposite of in. So if we check for apartments in this list, the nothing will just check for those rows who do not satisfy this condition. So we don't want any delivery country equal to Madagascar or Canada. So if I run the code, you will actually see that we have the customer ID respecting the rules we specify in the codes, 200, 400, and 400. We don't have nothing which is not actually listed in the list. And now the delivery country also satisfy the rule because we don't have Madagascar and we don't have Canada. Yes, so it's okay. And now this is how we use the or statement. So we use and if we have more than one condition. So if we want to filter our data, we have to make some condition, to specify some condition. But above, we was just dealing with only one condition. Yes, exactly like here. But here now, we have more than one condition. We have two conditions. The first one is customer ID should be in this list. And the second one is delivery country should not be in this one. So now, exactly like in the above case, here we are just going to make also two conditions. So it's basically one condition because we are using the or statement. So, but it's look like two conditions. So check if the price is below 10, or then check if it's below or is greater than 30. Yes, so it will check first if it's below this, and if not, it will check if it's more than 30. So, and that will display all the data from the product table. So if I run this, you have the results. So you have the price. All the price just have to be either below 10 or below or above 30. So you have it. The first one is above 30. The second one is below 10. The third one is just greater than 30. The following are just less than 10, and so the rule is respected using the or combined with the where function. Yes, and now you can actually also use the order by comment. So the order by comment is just to order your data. So if I say select all from order, where no, I don't use where here. Select all from order and order by customer ID. So basically by default, it order from the smallest value to the biggest value. So if I run this, we'll actually see that we decide in the code to order the customer ID, right? So here, look at the customer ID. We have the smallest value at the top and the biggest value following. And now we can actually choose the sense of the order. So I select all from order and order by customer ID ascending, and now order by product ID descending order. So if I run this, what is the difference with what we have above? It's provide another. It first provide another here based on the customer from the smallest to the biggest value. Yes, and then it's provide another order on based on the product ID. Yes, so the product ID will just be classified from the biggest value to the smallest value. So if we take, for example, the customer one, all the products of the customer one are just ordered in as a descending order. So here we have the biggest value at the top, and then when we are moving down, we have the smallest one. So moving now to another session, we have aggregation. Yes, so data aggregation. This also you will be using all the day. You have to deal with data analysis with SQL. You will have to aggregate things. So the basic aggregation function are just the count function, the sum function, the count distance, the maximum, the minimum, and so here actually I just write a code to compute the average price and the maximum price from the product table. So if I run that, it will just aggregate all the price and compute, yes, the average. And now compute the maximum. So you have the average price. Yes, and you have also the maximum price. So here, this is what I used to give another name to the output. So I can actually change. So if I say, for example, I write mean. So this is the mean of the price. Yes, so if I run it, it's just gonna change. So you have means of price. So you can do the same. Just go through. You have the tutorial. You can go through and do this. So here we are using the group by function with the count distance. So we say select delivery country and count distance the order from other tables and group by delivery country. So we are aggregating and group. We aggregate data and group them by a column. So the column we group by is actually the delivery country. So we aggregate the number of order, the number of distinct order. So this is set using the count distinct function. So we count distinct the ID from the order table. Yes, and we associated now the delivery country, and we group data on this delivery country. So if I run this, you will be able to see how many distinct orders do we have actually in our database from each country. So we have a table describing that. Now moving to the next step, and we have joining tables together. This also is very important because remember we make some relationship between our three tables. So in the other tables, we just specify that customer ID and product ID should be read as foreign key. So the foreign key are the one we are going to use when we need more information on the customer table or the product table, and we don't have it in the order table, for example. So see here, for example, we want to select the sum of all the price from the order tables. Yes, but we want to join the product table because we need the sum, the total amount of price of all the order, but the price is not located in the order tables. The price is actually located in the product tables. Let me go above so that you can see. Yes. So see here, this is the order tables, but we want to sum up the price of all the products. Yes, from all the orders. So we don't actually have the price here. So the only things we can use actually here to get our price is the product ID, which is actually here is a foreign key we are going to use to connect this table with the price tables. I don't know where is the price, with the price table here using the ID and then sum up on the price. Yes, so this is why we use to join two tables together. Yes, and that's why we are doing select sum of price, yes, from order and join the product tables on product ID equal to ID from the product tables. Yes, so if I run this, you will get the results. But below is also another way without using the join function. So we basically select from and sum up the price from order and then from product, and we use only the where function to say do this sum only where we have the product the product ID equal to the order, but equal to the product ID actually located in the order tables. So actually if we run that, we should get the same result. Yes, exactly like this. So it's working. And now this one is when we want to make relationship between more than two tables. So we are obliged to use the end statement because we have a lot of condition. We don't have only one condition. So we want the sum of all the price of orders coming from the order tables. But in addition, we need the customer name. So we want to add a third relationship, which is the customer. So we are going to use now the customer ID we provided in the order table as a foreign key. We have to use it and match it with the customer ID actually located in the customer table. So this is how we link three tables together, and we get the name from one, the price from the second, and the order from the third one. Yes, and then we group by everything we want and we order. So if I run, we have the results. And moving down, so this is a little bit more complex. So if, for example, we want to find the total amount of money spent on orders that are shipped internationally for each billing country, so this become more interesting. So here, the only thing you have to consider is the internationally. So internationally means that the billing country should be different from the delivery country. So Suppose, for example, you are living in Ghana and you want to buy something from online retailers website, then your provider should not be in Ghana. So if you say internationally, this means your provider should not be in Ghana. So let's say, for example, your provider is located in Nigeria, then you make your transaction from Ghana and you get your product from Nigeria. So this is a case, a use case. So now we write this code in two steps. There is a small code here where we have to specify that the billing country should be different from the delivery country. So here is the sign, the operator we use to specify that. Yes, so we just select the billing country, the delivery country, and we sum up the product price. And from the three tables where we linked the three, and we group by those two one, but we just specify having the bill country different from the delivery country. And then after that, we just name this subquery SHP, and from the SHP now we select the billing country and we sum up the price, which is also the revenue. When we call it the spend, and we group by bill and by spend. So you guys will explore this later. It's very simple and very interesting. So just a two-level query. We are using the subquery here inside, and we are delivering through this subquery. So now to finish, you have connection to how to connect to a database from Python. So there are a lot of ways to do that. You could actually be using MySQL. Here we are using SQLite, very practice for small analysis. Now if you need some more big analysis, you could be using MySQL, but you could also be using Microsoft SQL Server or Oracle or Microsoft Access or everything else you want. But the way to set up the connection is remain the same. So it's just actually this, but you can do more Google research to know deep about all that. Yes. So I don't know if you are still following my presentation. Are you there?
Yeah,
Yes.
Okay. Okay.
Yes.
So now this is all for the tutorial part. You don't have to worry because I'm recording this, and I also provide the screen recording for this SQL tutorial. No problem. You can download the file and follow at any time you want. And also you have the Jupyter Notebook file you can actually use. So there is no problem for that. And now I will just share with you so there is a quiz. No, not a quiz, but a challenge on this one. So I think it's this. Yes, it's that one. A lot of challenge for you, but yes, this one is good, I think. Yes, I think it's okay. So this challenge actually is so it's not so difficult. We just have to think about and write down what you think. So there is a contest. So this is just about an energy company. Yes, so they are actually selling solar panels. So now if client want, they could just get the solar panels with credit or not. Yes, so now I have explained everything in the contest. So read it carefully and see the format of the tables, the data you are provided. We provide those data as a CSV format. So you can just go in your today folder and you will see all those data. So you have the loan current details, so which describe the loan, so the credit. So you have the credit ID, you have the customer ID, you have the daily rate, and so you will get all the details about what each column means. So I describe them here. So table description, you have the loan ID, which is a loan identifier. You have the customer ID, you have the day elapsed. So you will read everything about this challenge. and you just write down what you think. Yes. So there is a person demographic. There is the sales details. So now, just looking at this, the person demographic actually contain information about the customers. So here we have the customer ID actually in the loan ID. So this is just can be just you can see this as a foreign key here, which will allow you making some connection with the person demographic to actually filters on country, region, profession, everything you want. So this is basically all information about the loan current details. This is all information about the customers, and this is all information about the sales. So the sales is more related to the product. So you have the product type, so and everything related. So now I run down some question. So the data set exists in CSV format, and you can actually download them and save them on disk to work on. So here is how you already know that I just write it to help you to set up your SQL environment. And now here you can be using your tables, your data, you drop if exist, and you import exactly like we did in the tutorial. You will be repeating the same thing, and you pass your data to your SQL for your connection. And now I run that some quick question. So write a SQL code to determine the total number of loan and now the total number of customer. So this is very easy. So you are just going to use the select function. I just talk like that. And here, yes, so you have to read and to provide answer. You write the code and you get the answer, and then you submit. So I'm going to show you the data. I think I have them. I'll load them all in your daily folder, but I also have them here. Low and current details. I think I have. Okay, it's here. Oh, let me. Okay. Yes, so this is actually the format of the data, columns, comma separated. Yes, so this is the format of the low and current detail. And where is the sales details? So we have it here. So you have the sales details here. Yes, and where is the what else? The person demographic. The person demographic, I think I have it also somewhere. Anyway, if I'm not finding that one, you'll get it in your folder. I think we have everything there. Let me see. Where is the person demographic? Okay, I cannot actually find it. Okay, it's here. It's here. So the person demographic is here and providing information about the customer, the country, the region, the profession, and everything you want. So now, I think this is all for today. And if you have some question, yes, I will just take some and let you continue working on your task and challenges. So by the end of the day, you will get your quiz of the day, and that's all. Yes. So if someone has any question, just ask, and I will try to answer. And also, I stay connected to the Slack channel. If you have questions, just write down. And as you are doing things, just write your question. Any question you want, we are here to answer. The Slack channel is made for that. Yes. So that's all for today. Any question? Okay, someone is asking something here. Let me see. Can the database name be any name we like? Or is also... yes, feel free to test. I didn't test that, but it's okay. I think you can just provide any name you want and test it. If it's work, it's okay. Yes, feel free to test that. Yes.
Hello, sir. Hello, sir.
Yes.
The quiz, when is it due for this one? I'll just talk about now, please.
Come again, please.
The exercise, the questions for
Yes,
today.
yes,
When is
yes.
it due for, sir? When is it due for?
Oh, this one is due for Friday. Friday.
Okay, Friday.
Yes.
So where can we go and find more resources on understanding this concept?
Please come again.
Where can we get more resources? Because I had problem understanding
Okay.
the last part of the where you put that p dot. I don't understand that part.
Oh, okay, okay. No, no problem. I think I just provide also the you have in the folder the screen recording that will be helping you understand it. And if you don't still understand, start making some research on Google, and you can also contact me. I will explain you things. So there is no problem. Just take your time to go through the Jupyter notebook and the screen the recording also. This one I also recorded that and I will share so that we are all on the same page.
Thank you very much, sir. Thank you. I really appreciate
Okay.
it.
Okay, sure. Sure. Okay, so all for today, and let's talk another time. Cheers. Yes.